All right, good afternoon, Lincoln Tech. This is Mr. Fallows. I'm the education supervisor here in Philadelphia. We're going to talk a little bit about solenoids. Now, solenoids are used in a lot of places in the vehicle to take electricity and turn it into mechanical movement. The place I'm specifically speaking about it in, and that we're going to do a little bit of testing on, is in the transmission. In the transmission, we use solenoids as an output. The computer will take inputs from the fluid temp sensor, the throttle position sensor, the accelerator pedal position sensor, and it'll have to make adjustments to where the line pressure in the transmission is sent. One side of one valve or in another, so that it goes through the valve body and can apply the proper clutch or band to either hold or release part of a gear set. And in other areas of auto trans, you'll find out that by holding and releasing gear sets, we come up with different ratios. But to get back to solenoids, the idea behind a solenoid is that we're taking generally any more in a vehicle, and this is a general rule, it's not hard and fast, but we're going to provide power to the solenoid at all times, and we will turn the ground for the solenoid on and off through the computer. Now, what are some other areas we might find solenoids in? Well, door locks. Door locks have solenoids. Vehicles that use a turbocharger might have a solenoid for its wastegate. You'll also see solenoids in variable valve timing. What operates the oil pressure, that's going to be a solenoid operation. So we use solenoids in a lot of different places in the vehicle. So how does a solenoid work and what is it? It's important to know that and be sure about that before we try to rock on testing it. So what I have right here, okay, is actually a solenoid drawn on the board, okay, power and ground. The electrical components are done in blue. The mechanical components are red. So this would be like a pressure control solenoid inside a transmission. Fluid comes in and is stopped. Now what happens is there's always 12 volts going through here. But when the computer gives a ground to this side, the electricity flowing through this blue wire is going to make a magnetic field. Quick correction, guys. Just looking at this a little bit closer, I wanted to make it very clear. The power is always being supplied, but the ground only is given when the computer commands it. So, I know what I said in the video. To make a very quick correction to what I said, power and ground aren't always there, so you don't always have 12 volts flowing. The 12 volts is always going to the solenoid, but it's only going to flow through when the computer gives it a ground. Otherwise, we don't have a full circuit. And no circuit, no flow. Back to the regular video. The magnetic field is going to pull this mechanical valve up. Now, the mechanical valve has a spring. That way, when I turn the ground off, the spring closes it again. When the solenoid pulls it up, the valve moves up and it makes this passage right here open. And that will allow fluid to go through. And usually it could do a little bit open, some open, depending on how often it gives the ground. Now that's a little bit of a different topic. It's called pulse width modulation or duty cycle. You'll learn about that, especially when you do your advanced electric class. It's a way that the computer can vary how long something is on to make it more open, less open. It's not a simple on and off switch. But this is the basic working of a solenoid. So we do have an electrical circuit inside. That electrical circuit should always give us some degree of resistance. So the computer has two ways of knowing if there's a problem. If it sees no resistance, then it knows, in fact, that this wire got shorted over there. So the electricity will never go around that coil of wire, activating the solenoid, pulling the valve up. However, if the computer sees what we call infinite resistance, or OL, on the meter, then we know that there's a problem in the fact that there's no circuit there. That coil never touches. At least in my experience in the field, more often than not, if I see a solenoid failure, that's why. Maybe the solenoid got overheated. Maybe it got contaminated. Something got stuck and it was trying to close or open that valve more, and it pulled too many amps. And so then it also got overheated. And in some way, it caused that wire to break. It got overly stressed. Now, this is how a solenoid functions. This is its basic workings. It's the same way a fuel injector works. Hint, hint, fuel injector is just another solenoid. So in our auto trans class, I have some valve bodies. We're going to take a look at a couple of solenoids to test whether or not they're good. We're actually going to turn it to ohms. Now, whenever you're testing something using, first of all, anytime we use a meter, but especially when we're testing ohms, we should double check our probes and make sure our meter is reading a good resistance figure. That shows that the meter should be accurate. Now, one of the examples of a solenoid that we talked about is the fuel injector. If we test it, so this fuel injector has about 12.9 ohms of resistance. Now that 12.9 ohms is telling us that there is definitely a circuit in there. Now, what I'd have to do is I would have to check and see, is that the resistance that is specified for that fuel injector? Now, off the top of my head, that is a pass-around part that we have here. I don't know exactly what vehicle that came out of. But I could go to All Data or Pro Demand to check the specified resistance for a fuel injector for a given vehicle. Now, the other thing that we could do is right here, I have the solenoid pack from a valve body from one of our automatic transits, particularly what we call an AOD. Okay, it's a Ford transmission, and I'll show you the plate after, but it's actually labeled solenoid 1, solenoid 2, solenoid 3. And we're getting 17.1 ohms on the one solenoid. $17 ohms on the next. And out of limits on the third. That would be our failure point. Now again, remember, an out of limit solenoid is going to read that way very often because something caused the circuit inside the solenoid to break. Remember, it's a coil wire wrapped around, in this case, a valve that's going to allow transmission fluid to flow. That valve will never open. Now, a solenoid can also fail mechanically. If we remember the spring that we showed on the board, we're going to go to that right now. Again, there's our picture of a solenoid. And as we're looking at it, remember, there is a spring up here. That spring can mechanically fail. So can the seal right here. Those mechanical failures can still cause us to have a problem where the solenoid is inoperable. Even though the checks we just did with the meter would prove that it's mechanically sound. All right, guys, another quick correction. All the tests that we ran in this video would have proved that it was electrically sound, not mechanically. Even master techs goof up sometimes. But just remember what the point of the video is. You can have a mechanical failure, but all the electrical tests look good. You can have an electrical failure where everything inside the solenoid that's mechanical is fine. Right? Sorry about that, but again, all the tests we proved would have been electrical, even with good. So, again, this was just a couple of minutes going over what a solenoid is, how it operates, and how we check it. Checking a solenoid is a vital skill for any transmission technician, and really a tech for any system of the vehicle.